Now, after understanding the process of manufacturing of cement, now we'll come to the most important topic, which is the chemical reactions in the cement. What are the chemicals involved? Being a civil engineer, this is one of the most important area in the concrete technology that one must master. Now, first, before going to the chemicals, let us first understand that why knowing the chemical compositions of cement and why understanding the chemical reaction is important. You have already gone through the web module and you would have understood that there are various categories of cement. Now, how these various categories of cements are there? The main reason behind is the difference in their chemical reaction. And out in the real world, when you go to the industry, then there is a wide variety of situations in which the concrete is required. There might be a very high temperature, there might be a very cold temperature, there might be a site which is very near to a moisture content, or maybe near to the ocean, or maybe into the ocean. There might be a site which is in the desert area. So all this site cannot have a same concrete. They might need a different concrete as per the structural need. So to acquire that strength which is good in a particular site condition, you must understand the chemical reactions that happens in a cement. So to understand the types of cement, you must master this topic, which is the chemical composition of cement. So first, there are three steps. First is the raw material which is used. What are those chemicals? Then those raw material is converted into a cement. Then what is that chemical? What is a cement as a chemical? And then when cement is used as a water, then certain chemicals reaction take place and byproduct are formed. Then what are those? So you need to understand the raw material as a chemical, cement as a chemical, and then the when cement is added with water, then the final product as a chemical. Now coming to the raw material, 60 to 70% of a cement is lime. So lime is the basic raw material which is required for the manufacturing of cement. Second is the silica. So 17 to 25%. This is the second most element by volume and weight. So basically lime and silica are the two major components which forms the cement. Apart from that, there are few other things which is in the very less composition. Then alumina, it is from 3 to 8%. Then iron oxide, it is only 0.5 to 0.6%. Then magnesium oxide, it is 0.1 to 4%. Then alkalis, that is potassium oxide and sodium oxide, it is also 1.3 to 4%. Then the sulfur oxide. So the presence of this raw material or this chemical have a huge impact in the final properties of the cement. Cement which have the alumina 5% will have entirely different property compared to a cement which is having alumina only 2%. So that is the prime reason that we must understand that what is the optimum percentage of this material required. Only then the cement can be used as a construction material. So basically there are 7 raw material: lime, silica, alumina, iron oxide, magnesium oxide, alkalis and sulfur oxide. In the coming modules we will understand that what impact or what reactions happens due to the presence of this raw material. Now we coming to a second step. In second step we will understand that once this raw material is processed into the cement, then what chemicals are formed. So basically cement is nothing but these four chemicals which we can see. First is the dicalcium silicate. So when this silica, lime, alkalis, magnesium oxide, iron oxide, sulfur oxides reacts in a kiln at a temperature of 1500 degrees Celsius, these are the byproduct, that is dicalcium silicate, tricalcium silicate, tricalcium aluminate and tetracalcium aluminoferrate. So when we say cement, we means these four chemical mixture. Now we understood that the cement is the composition of these four chemicals. Now the percentage of composition of these four chemicals have a huge impact on the properties of cement. A cement which have dicalcium silicate as a constituent compared to the other cement in which it is present in a less quantity, both will behave differently. In a coming module, we will understand that how the reaction and the behavior of cement changes when the composition percentage of this chemical changes. But as of now, we must remember that cement is composed of four chemicals, that is dicalcium silicate, tricalcium silicate, tricalcium aluminate and tetracalcium aluminoferrate. Now when water is added, then what happens? When water is added, then these chemicals reacts to form calcium CSH gel, that is calcium silicate gel, then calcium hydroxide, which is not a strengthening material, and heat. So when dicalcium silicate, tricalcium silicate, tricalcium aluminate and tetracalcium aluminoferrate reacts, then they form CSH gel, which is primarily responsible for the strength, and calcium hydroxide, this is the unwanted byproduct of the reaction, and the heat of hydration. Now let us understand about the heat of hydration in the next video.